Have you ever thought about what it would be like to encounter a force so strong that it literally bends space and time?
It's pretty hard to wrap your head around, right?
It is. And get this, even light itself can't escape. We're talking about black holes.
Yeah.
And today we are going deep.
I'm excited for this one. Black holes, they really challenge everything we thought we knew about the universe.
So before we get too far, let's start with just the basics. What is a black hole? Really?
Okay, so imagine a star, but way more massive than our sun.
Okay, got it. A big star.
Right. And it reaches the end of its life. It's burned through all its fuel. There's no outward pressure to counteract its own gravity.
So it just collapses?
Exactly. The core collapses. And if it's massive enough...
How massive are we talking?
At least 3 times the mass of our sun.
Oh, okay.
And when that happens, the collapse just keeps going until all of that matter is crushed into this tiny point.
A tiny point.
Yeah, it's called a singularity.
A singularity.
Mm-hmm.
So how could something so small be so powerful?
That's the mind-blowing part. The singularity has infinite density. It's like all that mass packed into an infinitely small space.
Infinite density. My brain hurts.
Yeah, and this creates a crazy strong gravitational pull. So strong that nothing, not even light, can escape the region around it.
So that region, that's what we call the black hole.
Right, and the boundary beyond which nothing can return, that's the event horizon.
Event horizon, the point of no return. Okay, so we've got these singularities surrounded by event horizons.
Mm-hmm.
But I've read that black holes come in different sizes.
Oh, yeah, for sure. So you've got your stellar mass black holes.
Okay.
These are the ones that form when a single massive star collapses. They're usually a few times the mass of our sun. But then you've got the supermassive ones.
Uh-oh.
These guys are found at the centers of galaxies.
Like our own Milky Way.
Exactly.
It's got a supermassive black hole at its center.
It does. It's called Sagittarius A.
I've heard of that.
And these supermassive black holes can be millions or even billions of times the mass of the sun.
Billions? That's insane. How do those even form?
That is the million-dollar question, isn't it?
It is.
They grow so fast, it challenges pretty much everything we know. And then there are these things called intermediate black holes, sort of a missing link between the stellar mass and the supermassive black holes.
Okay.
And then there's this idea of primordial black holes.
Primordial.
These are theoretical. They might have formed way back shortly after the Big Bang.
Okay, so we've got stellar masses, supermassive, intermediate, and even primordial black holes.
A whole family of black holes.
Okay, I have to ask this. What happens if you get too close to a black hole?
Well, let's just say it's not going to be pretty.
I read about something called spaghettification.
Ah, yes. As you approach the event horizon, the difference in gravity between your head and your feet becomes extreme.
Right, really?
Yeah. Imagine your feet are closer to the black hole. They experience a much stronger gravitational pull than your head.
Oh, right, because gravity gets stronger the closer you are.
Exactly.
So you're being stretched.
Yes, and this difference in gravity across your body, that's called the gravitational gradient. And it creates a stretching force, like a strand of spaghetti.
So spaghettification is real.
It's a real theory.
Not on my bucket list. But what happens inside the black hole, after you cross the event horizon? What's on the other side?
That is the ultimate mystery. Nothing can escape to tell the tale. Some theories say time stops at the singularity, but what that experience would actually be like,
we have no idea.
we can only imagine.
It is wild, though, that even the idea of time can be completely different near a black hole.
It is. It really challenges our understanding of the universe. And, all of this really makes me think about Einstein.
Oh, yeah, how so?
Well, black holes are basically living proof of his theory of general relativity.
Oh, all right.
They show us that gravity can actually warp the fabric of space-time.
That's pretty heavy. We've learned a lot about black holes, but there's still so much we don't know. Like Hawking radiation, what is that?
Hawking radiation, it's this idea that black holes aren't completely black. Yeah. Over extremely long periods, they slowly evaporate, releasing energy as particles.
So they shrink.
Very, very slowly. It has to do with quantum effects near the event horizon. We haven't been able to directly observe it yet, though.
That is amazing. So even black holes aren't immortal.
Not technically, no.
So what happens beyond the event horizon? Is it another universe? A wormhole? What's on the other side?
It really is a question that captures the imagination. We just don't have the answers yet. And that's what makes black holes so captivating. They push the boundaries of our understanding.
They do.
Yeah.
Okay, I've found some really cool black hole fun facts.
Oh, I love fun facts.
Okay, so get this. A teaspoon of matter from a black hole would weigh billions of tons.
I've heard that one. Hard to wrap your head around.
It is. And the closest known black hole to Earth is about 1,500 light years away.
That's still incredibly far.
Right. Space is huge. Okay, last one. Black holes can dance with each other.
They can.
Well, in binary black hole systems, they orbit each other. And as they move, they emit these things called gravitational waves.
Oh yeah, those are ripples in the fabric of space-time. It's how we can actually detect black holes colliding.
Right. It's amazing. So why do we care about black holes? What makes them important to us here on Earth?
Black holes are like the ultimate cosmic laboratories. They let us study extreme environments and test our understanding of physics. By studying black holes, we can learn about gravity, the evolution of stars and galaxies, and maybe even how the universe began.
It's like they hold secrets to the universe.
They do. The more we learn, the more we realize how much we don't know.
So black holes are cosmic riddles, pushing us to think beyond what we can see and experience here on Earth.
It's mind-blowing, isn't it? They challenge our understanding of reality.
They do. It makes you wonder if maybe someday we could even harness the power of a black hole.
That's a thought.
What could we do with that kind of energy? It's a question to ponder as we wrap up our deep dive into these cosmic enigmas.
Thanks for taking the plunge with us. Until next time.
Keep looking up.